may or may not be a good idea.
And welcome back to the morning show. It's Wednesday Wise Guy time, part 2 of our segment with our U of I physics professor, Matt Sellon. We're talking about fireworks and gunpowder and the kind of makeup of what goes into some of them.
Right, and so of course you never want to try this stuff at home because first of all, it's real hard to get the ingredients, and even if you could, you might burn yourself or blow yourself up or do something really bad or start a fire. So last segment we made gunpowder, and we saw what the ingredients that were required was. You needed something to be the fuel, okay, and that was a carbon, and you needed something to cause oxidation, something to provide oxygen for the reaction to happen, and that was the saltpeter, the potassium nitrate, and then the sulfur is mixed in there to basically make the reaction happen more efficiently. And so what I read, and this is the beauty of the internet, I read that, okay, well, you know, you can replace the charcoal, the carbon, with sugar, because that has a lot of carbon in it too. And so what I did was just figuring out how many carbons are in, you know, table sugar and so on, just figured out how much to put in instead of the charcoal. Right. And you get this mixture, which is kind of white. It's a little gray here because this thing was dirty. Sure. But it would be white with a little yellowish tinge, and it burns real good. And so if you step back, I'll throw this match in here, and you'll see what I'm talking about. It actually burns kind of better than the other stuff does. Wow. That's nice. Searing heat. So that's, yeah, okay. Now, what you can do, of course, is you sort of, when you make a Roman candle or something, you want that burning stuff to kind of burn down. Now, this probably isn't going to work real good because it's going to burn like this, and this isn't going to hold it in real good, but it looks funny. We can get Robert Reese to hold it. I don't think that would be a good idea. In fact, I think we should probably stand kind of back a little farther. Okay. I'd feel better if you stood right back, and we're going to try this one out. It's probably just going to go poof like that last one did. Whoops. We'll try that again. Robert Reese is... Wait, come here. Hold on a second, Matt. Okay. Here, let Robert... You ready? Oh, good. The safety... We got the extinguisher. Go! There we go. So I made the mixture in there slightly different so it would burn a bit slower. Okay. So it's kind of like a Roman candle. Colored balls. Boom. See how it's still going? It is going. That's nice. Just by varying the mixture a little bit, this has less sugar in it, about half as much as the other one did, so it burns slower. And so now you have this slow burn, and you can see that's how they make Roman candles. Oh, that's cool. Just by varying the mixture. How do they get the stuff to pop out of all of them? Sorry, I wrecked your cart. It's not mine. I don't care. Do whatever you want with it. Now, notice how aluminum burns, too. It does. I was just noticing that. Yeah. So that's pretty interesting. It almost looks like one of those snake things, you know, that just runs out. Yeah. So again, never try this sort of thing at home. No. But, you know, you can't really anyways. It's pretty good heat. And it's every now and then barfing out something green. What's that all about? I don't know. I've seen that before, but not with fireworks. So anyways, if anybody can email me when this all happened and it was first invented, I'll give you a couple of tickets to Streetcar Named Desire up in Rantoul this weekend. All right. Very good. Thank you, sir. Matt Sellon, U of I physics professor, showing us the makings of fireworks. And again, don't try this at home, kids. All right. We'll be back right after this.